Good day, students. Welcome to Step Up E-tutors Analytical Geometry Mathematics online tutorial. My name is Lerato, and we will be looking at some past exam questions, and this tutorial will be based on the Gauteng Departmental June exam paper for 2022. I will be tackling question 4 and 5. If you haven't subscribed, please join our wonderful family and remember to like and share at the end of the video. If you have any questions, also don't be scared to comment. Okay, so we are going to have a look at question 4, which reads, in the diagram below, the coordinates A, C, and B are the vertices of a triangle in the Cartesian plane. CD is perpendicular to AB with E on AB. E is the midpoint of straight line CD. The first question, 4.1, reads, determine the gradient of AB. So this is AB. So we're going to use the coordinates of AB to be able to find the gradient. So I'm going to first write down the formula down for you here. So gradient of AB is y of A minus y of B divided by x of A minus x of B. I'm going to write down the coordinates that we are going to be working with, which is A, which is -4, 5, and then B, which is 4, 1. Okay. Then we are going to substitute these coordinates into this formula. So we're going to have gradient of AB equals to y of A, which is 5, minus y of B, which is 1, divided by x of A, which is -4, minus x of B, which is 4. Then we'll be left with a positive 4 over -8. Then our final answer will be -1 over 2. The second question asks, determine the equation of CD. Okay, so it is important to notice above that this is CD. So when determining the equation of CD, we must notice first that we only have one point that has coordinates on CD. E does not have coordinates and D does not have coordinates. But one thing we can see clearly is that AB is perpendicular to CD. So when two lines are perpendicular to each other, it means that the gradient of those two, let me just write down on my side. So the gradient of AB times the gradient of CD is equals to -1. So in this case, we already have the gradient of AB. Therefore, it means that the gradient of CD is +2. Then we are just going to write down the normal mx plus y equals mx plus c linear function, substituting in the m since we already have it. Then after that, you substitute any point on the graph on the particular line. So in this case, the only one that we have in terms of coordinates is C. So you need to just detail out for your marker that we're substituting C. C is -1, -4. So we're going to have on the y, in place of the y, we're going to have -4 equals to, then we're going to have 2 times -1 plus C. Then this negative 2 is going to come over the equal sign, meaning that we're going to be left with c equals to minus 2. Therefore, our linear function is 2x minus 2. Next we are going to look at 4.3. It states determine the coordinates of E. Okay, so when we go back to our graph, we can see that E is the midpoint of CD, but unfortunately we are unable to use the midpoint formula because we do not have the coordinates of D to be able to calculate E. But another way to go forward is that we can see that line AB intersects line CD at E, meaning that what we can do is find the linear functions of both AB and CD and then equate them. Then we'll be able to find the coordinates of E. So according to what we calculated in 4.3, we already have the equation for line CD. So let me write it down. So it's YCD equals to 2x minus 2. What we need to find now is YAB. But already according to 4.1, we've calculated the gradient of AB. So that means we have y equals mx plus c. In terms of the m, we already have 1 over 2x plus c. Then what we need to do is substitute one of the coordinates of AB between A and B. So I'm going to choose to substitute in B. Then in place of the YAB, we're going to have 1 equals to negative 1 over 2. And then we're going to times it by 4 in the place of x plus c. And then when you calculate this out, we're going to get a negative 2 plus c equals to 1. That means c is equals to 3. From there, we are able to see clearly that we have our linear equation of AB. So YAB equals to negative 1 over 2x plus 3. The next step is to equate the linear function for AB with the linear function for CD. Why? Because it's where they intersect at point E. And then we are going to write them out and say negative 1 over 2x plus 3 equals to 2x minus 2. Then we're going to take variables to one side and numbers to the other side. So we're going to have negative 1 over 2x minus 2x. And on this side, we're going to bring over the 3. So we're going to have negative 2, negative 3. Next we are going to have negative 5 over 2x equals to negative 5. Then you are going to times on both sides by negative 2 over 5, because what you do on your left, you do on your right. And then we are going to be left over with x equals to a positive 2. Then we are going to substitute x equals to 2 into one of the equations, either CD or AB. So in my case, I'm going to substitute it into equation CD. Then we're going to have y equals to 2x minus 2. Then we're going to substitute in the x plus 2. x equals to 2, apologies. So we're going to have 1 y equals to 2 times 2 minus 2. That means your y is going to be 2. It is important to remember that they ask for coordinates of E, therefore you should leave your answer in terms of coordinates. So we've calculated that our x value is equals to 2 and our y value is also equals to 2. Okay, so next we are going to look at 4.4, which says determine the coordinates of D. When we look at D, we can see that, okay, so it's line CD, and what we have are 2 coordinates, so we already have the midpoint here. So what we can do is use the midpoint formula to calculate the coordinates of D. So how we can do that is saying x of D plus x of C divided by 2 equals x of E. The very same thing with y, the y coordinate, so it's y of D plus y of C divided by 2 equals y of E. So we already have what it's equals to already, because we have the coordinate of E as 2, 2, 2. Okay. Then next, we also have the coordinates of C. The coordinates of C as -1 to -4. Let's just write it down here. -1, -4. Okay, so then we are going to substitute in the x of C. So we're going to have x of D minus 1 divided by 2. And then we multiply both sides by 2. Then we'll have x of D minus 1 equals to 4. That means x of D is equals to 5. And then on this side, in terms of the y coordinates, we have y of C. So we're going to say, okay, so y of D minus 4 divided by 2 equals to 2. We multiply both sides by 2. Then we'll have y of D minus 4 equals to 4. That means y of D will be equal to 8. It is important to remember to leave your answer as a coordinate. So D will be 5 in terms of the x, and the y will be 8. Okay, so we're going to look at 4.5, which says determine the equation of the straight line passing through point D and parallel to AC. Okay. So if it's passing through D, let's just, we won't be able to see D completely on our side, but then let's say D starts here going down like this, right? Because it's parallel to AC. So it's going to start there going down, right? Okay. Then one thing that they said that was very important in this particular sentence is that it's parallel to AC. Parallel to AC. Okay. What does that mean? Okay, so next we're going to look at 4.5. So with 4.5, it says determine the equation of the straight line passing through D and parallel to AC. So it's important to realize that it's saying passing through D parallel to AC. So let's say the line will be something like that. So it's passing through D parallel to AC. Another thing you must know is that if it's parallel, that means, so if AC is parallel to the straight line passing through D, that means that the gradient of AC is equals to the gradients of the straight line. Okay, so what we have is that we can calculate the gradient of AC using the coordinates that we have. So we're going to say coordinates of A and the coordinates of C. So you're going to say 5 minus 4 divided by -4 minus 1. Then we're going to have a positive 9 divided by -3. That means gradient of AC is equals to -3. And then from there, we know that, okay, gradient of AC is equals to the gradient of the straight line, meaning that the gradient of the straight line will also be equals to -3. And then they asked us to find the equation, right? So we have the normal y equals to mx plus c. We substitute in the -3, so we're going to have y equals to -3x plus c. Then we substitute 1 point on the graph. So we had calculated that d is the x value is 5 and the y value is 8. So we're going to substitute in d, so which is 5, 8. So in the place of y, we're going to have 8. And then in the place of x, we're going to have 5. That means c is equal to 23. And then our equation of the straight line will be equals to -3x plus 23. I hope that it's clear. Next, we are going to look at question 5.
Thank you very much for taking part in our lesson today. We'd really appreciate if you would like and comment below if you have any other questions that you'd like us to answer. And if you'd like private tutoring lessons from myself, please email stepupetutors@gmail.com or WhatsApp the number 083 343 8245. Thank you. Bye.